Hello, welcome to this live stream about an introduction to 3D printing. Today we're going to take a look at the 3D printer that I've got here and some software required in order to get up and running. We'll also talk about some tips and tricks about printing along the way. I've had this 3D printer now for over a year, and it's been really great to build different project enclosures and to build like board game accessories and a lot of different things that I've had the opportunity to build. And unlike a normal printer that you'd buy with ink that you kind of just plug and play, the one thing about 3D printers is that there's definitely a lot of kind of tinkering and adjustment of settings to make it work the way that you want it to. It's been a really fun project. I'm printing a lot of really cool stuff. So before we kind of get started and talking about the software, I'm just going to do an introduction to 3D printing. All right. A little bit about me. My name is Chris Black. I'm a software engineer, instructor, and maker. You can visit my blog at blackcj.com/blog or follow me on Twitter at ChrisJBlack. We're going to take a look at a quick example project that I was working on for one of the previous IoT Hack Days. And here's a setup of the project that we ended up building. This was a low-cost thermal camera that you could use to kind of scan for different heat loss within your house, or find troublesome outlets in your house, or really just use it for detecting thermal imaging where normal camera wouldn't be able to detect heat sources or cold spots, and so this camera would allow you to do that. So this is what it would look like if you kind of wired everything together with a breadboard. Not very practical in terms of walking around and actually using this product. So at the event at IoT Hack Day, we wound up with what you see here on the left, a lot of exposed wires. Everything was just kind of bundled together. The first pass that I made at an enclosure was the white enclosure on the right, which had a little button to kind of take a picture and sends it up to the server. And then the kind of final iteration of that I put together was right here, and I'll show you an example of that. Actually, right now we can switch over to the web camera. Right, so the final product was this enclosure that I built that has a little screen on the back to show you the temperature and has the little thermal camera on the front. I built a little strap on here as well, and then it's got micro USB for charging and an on and off switch. And then inside, right, we've got a little bit of support that I put together so that everything would fit together nicely. And then the switch and then the microcontroller and the battery are all in place. And so this was put together after the fact. I put a lot of time into measuring all of the components and making sure that everything would fit in place. But it gives it more of a slimline feel, and it makes it easier to carry around. So it definitely makes this product a little bit easier to use and something that would make a little bit more sense to kind of walk around with. All right. So the printer that we'll be using today is a PowerSpec i3 Mini, and this printer I purchased at Micro Center for $150. I will tell you that if you want to do 3D printing, the cost of the 3D printer does not necessarily equate to quality. You can get great quality prints with a low-cost printer. It's a lot in the settings and how you configure the profiles in order to go print. I would say that there is another printer that I'll kind of link to after this that would be my recommended printer. It's in about the $400 price range, and I think it's a really good compromise in quality versus the cost. But this has been a great printer to get into 3D printing. My only complaint with the PowerSpec is that it does have a very limited bed size. So as you can see from this picture here, the bed size is only about 4 inches by 5 inches in terms of the width on that, and it is limiting in terms of what you can print. Some of the more expensive printers have a little bit larger beds, so you can print bigger objects on your printer. But I've been really happy with this printer, and I've gotten a lot of use out of it. I've gone through at least, I think, 5 or 6 spools of filament since I've gotten it, and gotten a lot of prints out of it, and it's still working great. So what is 3D printing good for? 3D printing is good for rapidly iterating over a product design. So if you have an idea and you want to bring a product to market and need an enclosure, yeah, 3D printing is great for iterating over those enclosures and prototyping, and finding out that switch doesn't really fit in that spot, and really going through all of the motions in terms of validating your product design before you go to mass production. So it's really good for do-it-yourself projects, or things like if you have a board game and you lost a piece and you need to replace that piece, or augmenting board games with magnetic enclosures that you can kind of snap things into. It's a really good way to use printers. The other thing you can do with 3D printing is if you're into tabletop gaming and you want to print out little miniatures, 3D printing can be used for that as well. 3D printers are not intended for like mass production. It does take a while to do a print, and if you're going to be printing out 1,000 widgets or 100,000 widgets, there are much more economical and faster ways to do that than 3D printing. And so it's not intended to print out 1,000 of something. 3D printers are much better for prototyping and iterating, and once you have the design that you want, if you do want to take it to market and print 1,000 of it, then there are other places online that you can go to kind of create more of a permanent molding, and for a lower cost, print out a lot more or create a lot more things. So just general considerations, thing to keep in mind when you're getting into 3D printing. Like heat from your components or microcontrollers, like if you have a temperature sensor, heat from a Wi-Fi chip can increase the ambient temperature. So if you have an enclosure and you put your temperature sensor right next to your microcontroller, then it's going to be inflated in terms of heat, because your enclosure is going to trap that heat inside and keep the heat in there. And so you'll want some venting and or separation of components in order to remedy that. Some sensors are going to require airflow or sunlight, right? If you built an airtight enclosure, but the enclosure is supposed to monitor air quality, right? You're not going to get that air quality. You're going to require some airflow if you want to get humidity and or air quality readings from your sensors. Or if you need access to sunlight, you're going to have to build out some sort of transparent and or opening in your enclosure to pick up that sunlight and that potential airflow. The other thing to keep in mind is whether your project will contain a battery, and if so, what kind of battery life do you expect to get? So with an enclosure, you might have a portable product that you're using on the go, and thinking about how long you're going to want to be able to use that before you need to charge it up. All right, a few more considerations here would be, are there any buttons or LEDs on your microcontroller that you'll need to be able to access? So making sure that you're considering that as you build this out, especially for debugging and development purposes. And then will various parts of your enclosure kind of fit together? How are you going to put everything together? Is it going to have, I found that the nylon screws are a great way to kind of put all the pieces together and get everything connected up. Some of the components will fit together with some friction if you design it so that your lid is close enough and fit. Sometimes it'll just pop on and pop off like I did with that camera enclosure. But in terms of going to market or having a product, you'll definitely want to have something more secure like screws or glue or something like that. And then early stage prototypes, I think that the hardest thing about making the enclosures more compact is getting rid of those excess wires. And so having wires move like around in your enclosure are definitely going to take up a lot of extra space. So the more you can cut down on having excess wires, the more you can embed everything on the microcontroller, the better. Right. So the other thing to keep in mind when you're doing 3D printing is what material you're going to use. We're going to use PLA plastic today. but there are other materials out there like ABS. There's wood PLA. There's a whole bunch of other materials that you can use with your 3D printer. And with the materials, keep in mind that each type of material or plastic is going to have pros and cons. Right? The plastic PLA that we're using is very inexpensive and widely available, but it's not going to be good for something that's going to get real hot because it has a low melting point. So if you use PLA plastic and you're building a phone holder for your car, right, and in the middle of the summer it gets really hot, that could melt the plastic and melt the product. And so something like ABS is going to have a higher melting point and be more usable in terms of warmer environments. And so keep that in mind as you select your filament. If you're just prototyping or building some enclosures, your PLA is going to be a great way to do that. If you're going to build something that is going to be more heat resistant, you're going to want to use something like ABS or a stronger plastic. And the other thing to keep in mind is that a lot of the 3D filaments are not going to be food safe. They're not going to be dishwasher safe unless you get specific filament. So if you do need to use a plastic that's going to be food safe or dishwasher safe, you're going to have to do some research and make sure that whatever plastic you're using is going to support that temperature and be able to pass that through the dishwasher and heat that up. And so keep that in mind as you design your product, that the type of filament that you use will be very important. And the other thing to keep in mind is you want to avoid overhangs, because whenever you have an overhang, you're going to have to build support for that overhang. As you're thinking of a 3D printer, if you have like a tree that has a lot of branches that go out, all of those branches are going to need to be supported somehow in air. And so the more overhangs you have, the more material you're going to use as you build support up for all of that. And we'll talk about that in a little bit more detail in a little bit. And let's see, 3D printed items are subject to melting at their melting point, and so keep that in mind. That something like a hair dryer or a hot car has a potential, or a dishwasher have the potential to melt the different certain types of plastic. So the PLA wood filament, here's an example of a project that I did. I made some dice boxes and used some wood filament. And wood filament has a small percentage of wood fibers in it, and that will allow you to stain it. So it will pick up on stain, and you can have more of that wood type feel to it, and it will look and feel a little bit more like wood. And so it's good for making things like chess pieces or dice boxes or different things that you might want to mimic more of a carved look or a wood type look to them. It can be stained. If you are going to print on wood filament, one of the tips I found online that was very helpful is to disable retraction. So 3D printers, as they print, as they're moving around and distributing the plastic around your print, will retract that filament a little bit by default. And when you're using wood filament, enabling retraction can clog up your printer nozzle. And with retraction disabled, I have not had any clogs in my printer nozzle from the wood filament so far, crossing my fingers. I have gone through almost 2 full spools of wood filament without any issue. All right, so tools that you might want to invest in if you are going to get into 3D printing are a caliper, which you can see on the image there on the right, and that allows you to measure things so that when you're going to design something for your 3D printer, you know what dimensions to build it at. Pen and paper are really nice to be able to sketch out and design your prototypes before you work on your computer. Multimeter is going to be good for measuring different voltages and determining how long your battery life is going to be on your product. And then switches and small screws will make some of the components more accessible as you're building that out. So the software we'll be using today is called OpenSCAD. I really like OpenSCAD to design for 3D printers. Using just a little bit of code, you can make some really cool enclosures and designs. Other popular software would be Fusion 360, FreeCAD, and MeshMixer. I've used FreeCAD and MeshMixer to do designing as well. And those tools are, I think they're good, but they're a little bit more complicated to use. And I'm used to being able to write code, and so OpenSCAD for me is much faster in terms of being able to design and develop something. The other software that we'll be using is something called Cura. And Cura is what we're going to do. So the OpenSCAD, all of the software programs listed here allow you to design 3D models. And then once we have that designed 3D model, we'll end up with what's called an STL file, which is a representation of our 3D object. And we'll take that STL file and we'll bring it into software called Cura. And Cura will take that 3D model and break it down into all of the instructions that your 3D printer needs to print that 3D model. So Cura will add support where support needs to be added. Cura is where we'll define our layer height. It's where you're going to define your print speed, and the quality of what you end up with is all defined in Cura. So these software programs are how you design your 3D model, and then you'll take that 3D model and then turn it into instructions for your printer using Cura. And then lastly, we'll be using Octopi to do the print, but you could just as easily take the file from Cura and put it on an SD card and put that in the printer instead. And I will link to the all of these slides are available for free, so if you want to be able to click through the links, I'll post those after the fact. All right, let's take a look at a demo. So we're going to take a look at a demo of some software here. So the first thing that we're going to do is take a look at OpenSCAD. And OpenSCAD, again, is software that we can use to do our 3D prints. If you would prefer to, I guess before we get into designing for 3D prints, if you prefer to just, download an existing 3D print, you can go to a website called Thingiverse. And if you go to a website called Thingiverse, there is I'll bring that up over here, bunch of other people that have already designed a bunch of cool stuff, and you can click through on one of those, and it will show you all the instructions you need to print that thing. And so what we can do here is take a look at let's just say this print here, and if you download all the files, this will most likely contain some STL files that will be included, and should have everything you need in order to do this print. And so Thingiverse is a great way. Here we go. Here's an example of what each of these components will look like. So this looks like this grab release phone stand here is going to contain a lot of different components, and I like that this is colorized like this, so you can kind of see what might be different. But you're not going to print something like this all put together. What is often going to happen is with a lot of 3D prints, you're going to print individually all of the parts and then assemble that. And the reason that you might do this instead of building it all together is so you can get some of those gears and movable parts. And if you print everything individually like this, it will allow you to have less support. So you can see here that very few of these will have overhangs if printed correctly, which makes it so that you'll be using less filament. So you would go through and print all of these items, and then assemble that all together after that. So Thingiverse is a great way. You can download the files, you can search Thingiverse, and if you do design something that is you think other people would like to use, definitely add it to Thingiverse and contribute to kind of this open source community of 3D printed things. All right. So give me just a moment here to load up OpenSCAD, which we're going to take a look at next. All right, so we're going to be using OpenSCAD to generate a just kind of a simple box basically, or sphere, whichever we kind of decide, and then we will print that. All right, so the first thing that we're going to do is load up a new, open up OpenSCAD and load up a new design here. Okay. So in OpenSCAD, you can see here that we have on the left, we have where we're going to write our code. And as we write code and save that, our design will appear here on the right. Unlike other 3D designing software where you actually design in the visual editor, with OpenSCAD, everything that you want to appear in the visual editor must be written in code. So, for example, if we wanted to have a cube, we can write cube and then pass in some our width, which we're going to do an array here, and we're going to do a width of 20 by 20 by 20, and this is in millimeters. And then when we save this, demo. Yes. All right, so when we save this, it creates a cube on the screen. And that's pretty cool. So if we want to move around, we can kind of click and drag. You can right click and move around to drag and move the object here. On a Mac, it's going to be a control click to move that around. We can see here that we have a cube. Zoom out, and if we wanted to, we can export this as an STL file, send it to our 3D printer, and our 3D printer would print a cube, which would be pretty cool. So if we wanted to, for example, make more of an enclosure, we might want to create one cube and then take the difference of another cube out of that cube. So if we write, there's a function called difference, and if we use the function difference, it will take the difference of the first thing and then it will subtract out the second one. So if we did the difference and we created another cube of the exact same size, what this should do when we save it, let's see here, I'm going to make this one just a little bit smaller. Actually, 20, try doing 21. There we go. That's going to give us a little bit more of a representation here. So you can see here that this is kind of choppy. You can barely see it. If we take the difference of one cube and another cube, we're left with lines that are so thin we can barely see them. So what it did is it subtracted one from the other. So what we would probably want to do is leave a little bit of space. So let's just do 1 millimeter on the left and the right. And we'll save that. Now we can see here that we've allowed for some space, but it's still up against the edge of two of the sides and on the bottom too. So what we might want to do here is move that cube, and what I'm going to do is put a hashtag in front of that, and that's going to show us, if we put a hashtag in front of one of our lines, it's going to show it in red what that looks like. So this is the cube that we're taking as a difference out of the other one. So the other thing I'm going to do here is I'm going to translate this, and we are going to translate this 1 by 1 by 1. So we're going to move it forward, translate the second cube a little bit there and save that. And now we can see here that what we've done is we've created a box that has 5 sides to it. So it has our bottom, it has the left, the right, and the top is being removed by that by the thing that we took the difference of. So here, just got a simple cube that we can then, if we wanted to, send to our 3D printer, and it would print that out. So what I'm going to do is, if we wanted to print this, we could export this as an STL. Error, nothing to export. Before we can export as the STL, we have to first build it. So the render that we saw here was just a quick render. And so what we can do here is save this to the desktop, demo.stl, save. And what that will do is it will create a file that represents this 3D model. So OpenSCAD allows you to create different things like cubes and spheres and lots of different shapes. And you can do, I designed the entire enclosure for the 3D camera. I've designed some dice boxes, a lot of different things you can do in terms of OpenSCAD. You know, if you wanted to design like a miniature or something that had a lot of detail, OpenSCAD would not be the application to use. If you don't think you can represent something in math, then you'd want to use one of the other software packages like Fusion 360 or Mesh Mixer or FreeCAD that would allow you to have more granular control over kind of like a Photoshop type tool where you can edit the object more in any way you want. So OpenSCAD is great for designing something like an enclosure because they're generally something that can be mathematically represented. So we've designed this box here, and now we're going to try printing this. So before we print the box, what I'm going to do is open up Cura. There are a lot of different versions of Cura out there. They should all be work very similarly. So what I'm going to do is minimize that, and I'm going to take that file that we just created, and I'm going to go ahead and drag that. So here's the STL file we created. I'm going to drag that right there. All right. So we designed it in OpenSCAD, and now in Cura, what we're going to do is actually create the instructions for the 3D printer. So this is the part it's going to be really important here to keep in mind. Let's see here. Give me just a moment. All right, so we're going to talk about a few things here. We're going to talk about the quality. So the layer height here is something that's very important. A smaller layer height, so 0.1 millimeters, is going to be a better quality than a 0.3 millimeter layer height because it's just smaller steps as it builds this enclosure. And the shell thickness is going to be kind of that thickness of the outer edge here that it's going to create. The other thing to keep in mind that will impact your quality is the print speed. So if the printer that I have, I think it prints up to 70 or 80 millimeters per second, but I've found that printing at 30 or 40 will give you much better quality, and 50 or 60 gives you kind of that medium quality, which is good enough for enclosures. But I found that if I print at the highest speed, it just is not the quality that I want out of my prints. And then the printing temperature is going to be based on your filament. And so the filament that I have has a melting point, I believe it's between about 190 and 220. And so I'm kind of setting it at about 215 for the printing temperature. Okay, a few things to talk about in the advanced section. And this is that enable retraction. So if you have wood filament, you would want to uncheck that box. Actually, before we go to advanced, we're going to talk about support. So support, we're going to put support everywhere. And the platform adhesion type is going to be BRIM. So the platform adhesion type is what's going to appear around the edge of our design, and the BRIM is going to do two things. It's going to help our print stick to the bed. Because one of the potential issues when 3D printing is your prints will sometimes peel up off the bed as it's printing, causing warping and just problems in the design. So the BRIM is going to appear around the edge of the design, and it's going to help it adhere to the print bed. The other thing that the brim is going to do is give the printer the chance to get a little bit of the filament out, and so it kind of helps make the filament come through a little bit more cleanly once it actually gets to your print. So I'm going to show you what that brim will look like. So if we're talking about a brim, here's a 3D printed design, and you can see here that there's kind of that semi-transparent edge around there that I would remove after the print. But you can see here that it was printed on the bed, this way down on the bottom, and it had a brim. And the other thing that I did is I set a little edge on the brim too, to help provide additional support and prevent peeling with the print. So again, this is something that you'll just rip this off once you're done with the print, but I want to kind of show you what that looks like. And so it has the brim, and then also has this is called the draft shield to help with the adhesion on the print. Right, and the other thing to note is that I printed this with this side up, because whatever is on the top is going to be better quality than whatever is on the bottom. You're going to kind of get, especially if you have support, you're going to get kind of a rough surface, or in this case, because it was flat, it's a very smooth surface, but the quality is going to be better on the top of the print. And so, for example, then on the top of this, I printed this one this way so that the support was on the bottom, because I can put some material on here, some felt, to kind of use this as a dice box and roll into it. And so this is how I printed this one on the bed like that. And here's an example of some wood filament if you're interested. Here's a little tree that I've got with using wood filament. And you can see here that some of the support is still attached there and stringy. I did remove a lot of it, but some of the support is still on there. But this is a little tree. And then a couple other things here is we've got like a little miniature that I printed. Let's see if it'll change the focus. Looks like I'm going to have to bring it out a little bit here to get the focus on that. But this is a little miniature that I printed that turned out pretty good quality. I did a very slow print speed on that and a small layer height, and it ended up turning out really well. Okay, so back to our design. So again, we've got our design here. We designed it with OpenSCAD. You can download something on Thingiverse and drag your STL file onto Cura. And so once we have what we want on Cura, on the basic, we'll go to advanced. The nozzle size, this is specific to your 3D printer, so check that. The retraction speed and distance, we've got the initial layer thickness, and this is really important. So with the build plate adhesion, when you do bed leveling for your 3D printer to make sure that the 3D printer bed is level, the initial layer thickness will, having this number at 0.3 will make it significantly easier to remove your prints from your print bed. If you change this, then you're gonna have to re-level your printer, and I've had issues with setting this at 0.1 where the prints are almost impossible to get off the bed. So having a little bit higher, again, it is saying that in the little pop-up here, having this at 0.3 will make it a lot easier to get off the print bed. And we have a tool that we'll use for that. We got our travel speed, and I'm going to enable the cooling fan. Before we actually go through and print this, the other thing that you'll want to do if you're just getting started and haven't done this before is you will want to make sure your machine settings match the machine settings here. So I have all of the machine settings set to my printer, and this should be in the manual of your printer, all the settings that you need in order to print that. You'll want to set your bed size so that it's going to restrict the design to the size of your print bed. All right. So we've got everything here. I'm going to take a look. If you select this view mode here, we're in normal. I'm going to take a look at layers. So if you do a view mode of layers, it will actually allow you to see each layer as it's being printed, what it's going to look like. So we start here, the very first layer, and we can see that the printer is going to move over here, start at this corner, and it's going to first do this initial layer with the brim and the bottom of our design. And then it's going to slowly build up. And we can see here that there is just a little bit, going to be a little bit of space in our wall there on the inside as it builds this up. And it's going to print this layer by layer until it gets to the very top, and then we'll be done. And it shows us where we're going to finish our print. So if you're interested in seeing, any support or overhangs, I wonder if I could change this normal. And if I were to, for example, rotate this, which we would want to print it like it looks here, but if I, for example, were to rotate this 90 degrees so that we have the box, it wouldn't be able to print the top of this without support. And so now if we look at our layers, we can see here that it's going to build all these layers of support. And you can see here that it's got these support beams that it needs to add in that we would then remove when the print was done, but it's got this support that it can use to allow it to print that top layer. So again, that's why we want to avoid having our designs, like if you can print this without support, it's better to flip that, because we're using a lot of extra filament inside here to print this out. Okay, so I'm going to go back, reset that back to the way it was. It will tell us how long it's going to take to print it. And so I'm going to go ahead and save this to the file path. I'm going to save it to the desktop. And when we save this, it's going to save it as G-code. And the G-code are the instructions that we need in order for our 3D printer to print. Okay. So first thing we needed was an STL file. You can either download your files from Thingiverse or create them using a software like OpenSCAD, FreeCAD, Fusion 360. Once you have an STL file, you open it up in Cura and set your properties and parameters and instructions for your printer. And once you have your G-code file, which is instructions for your printer, then you're going to either put it onto a micro SD card and plop that into your printer, or if you have something like Octoprint set up, and some 3D printers have Wi-Fi capabilities, you can remotely send the files to the printer. So the next thing I'm going to do here is upload this file to, log in to Octopi. And so this is a Raspberry Pi set up on my local network that's connected to my printer. Okay. And my printer is currently offline. I haven't turned it on yet so that you don't have to listen to the fan the whole time. So I'm going to upload that file that we created from the desktop. And that was the G-code file that we're uploading. Yeah, and if you'd prefer to put this on a memory card, that would work as well. But I'm going to upload this file. And then after uploading the file, we have the demo.gcode, and once we connect to the printer, it will let us print. I'm going to switch over to the web camera and show you the printer. Okay, here's the power spec printer. And I'm going to go ahead and turn this on. There's a power switch on the back. Fan is a little noisy. Thought about replacing the fan or adding some sort of like a silicone spray to help make that a little bit quieter. But since this is in the basement for me, I'm not as concerned about the fan being noisy because it's not normally up here on the living room table. Okay, so we have our printer. It's turned on. I'm going to go back to the software. And we are going to connect that. Give me just a moment here. All right. Okay, it's something we're going to connect to here. Detecting baud rate. Right. Give it just a moment. Okay. And now that it's connected to the printer, it says it's operational. So I'm going to go ahead and get my camera situated here. And we're going to try this print. So I'm going to go to the demo G-code and hit print. First thing it's going to do is warm up the printer. The printers get very hot. We're talking 215 degrees Celsius, and so if you'll want to make sure that you don't ever touch the nozzle of the printer, you're going to want to wear safety glasses if you're going to be looking very closely at the printer, and you just keep in mind that these printers get very hot, and so you want to avoid being too close to the nozzle as it's actually printing. So this is showing me that the printer nozzle is getting warmer, and once it gets to 215 degrees, it's going to start the print. So I'm going to switch back over to the 3D printer. And we're going to wait for it to get up to temperature, and then it's going to print that out. All right, we're getting pretty close. All right, we're at about 205 degrees, so we're getting almost there, 210. At this point, we can start to see some of the filament that is coming out of the nozzle there. And then what the printer is going to do is it's going to actually kind of remove that filament by pressing down on part of the print bed in the corner before it gets started. So it's going to move over to the corner of the printer. Lower down. There we go. All right, so looks like we've got some technical difficulties with this specific G-code file. So I'm going to go ahead and cancel this print, and we'll take a look at that in just a moment here, see if we can figure out what the settings are that might be broken with that file. But just to get things started here, I'm going to stop this print. cancel here. Oh. Looks like we didn't have any issues there. Alright, I take that back. It was... there we go. We canceled the print. Alright. We're going to go hit quick settings. I'm going to move the nozzle. Alright, give me just a moment. I'm going to grab the tool that I'm going to use to remove the filament that we have. So I've got a newer version of Cura here that we're using, and I was not expecting it to kind of go into the air back before it came down onto the plate. So I'm going to remove that, and we're going to redo this print here in just a second. Alright, so this is going to be an example of how we would get, we're going to use this tool here that came with the printer, and we're going to get under the edge of the brim here and peel that up, like so. We peel that off the printer, and we're going to hit print on that one more time. Alright, let's do that again. Okay, the printer's heating up again. This time it won't take quite as long. We're at 130 degrees already from last time. So a few other tips for 3D printing. When you do start a print, it is always good to watch kind of that first initial layer, or check on your print after that first layer to make sure that everything is working the way you want it to and it is adhering correctly to the brim. The other thing to note is that you know, the layer height really has the most to do with the quality of the print and what your prints will look like. You can, with a higher layer height, definitely see those lines throughout your print. And then when it prints something, for example, if you had like a sphere or something that had, you know, a lot of space inside of it, I'm going to show you here in this print, you can have what's called infill density. And you can see here that the infill density, to reduce on the filament that we're using, it prints like a grid inside. So you can set the percentage of infill that you want based on the print. And so this was you know, a switch controller adapter, and the print was started to warp a little bit, so I took it off the bed before, or stopped the print before it was done. You can see that it was halfway through printing this controller grip here, and it still had the infill density of, you know, about 20% or so. And so that allows you to save filament. It makes your end result a little bit lighter, and so that's something to keep in mind. If you're going to be printing a miniature or something that you want really high quality and really high resolution, you will want 100% infill density just to really improve the quality. But for something like a switch controller here, you know, I wasn't too concerned about the specific quality on that, so I did not put that at 100%. So it's a great way to save on filament cost and make your prints a little bit cheaper, to set the infill density on that. All right, so we're gonna try this again. Alright, so we've got our 3D printer going. Back up a little bit here, see if we can get a little bit sharper image. Right now it's printing the brim of our print. The other thing to note here too is that all of these accessories that are in white here, so this fan cover and this piece down here, I 3D printed those. I also 3D printed these stabilizers here to help the bed to avoid too much wobbling there that was impacting my prints. So I was able to kind of 3D print some accessories to help improve the printer. And right now it's printing the first layer of that cube that we created. The other thing that I'm going to do is just remove this blob there. Alright, it's printing the next layer. I'm going to try to get a better angle here. You can kind of see what the printer is doing. Right, so what it's doing right now is it's melting all of that filament into place. It's feeding the filament from the spool that I have, and it's going all the way through all of this tubing, from the spool, through the tubing, and it's being fed back down into the nozzle. The nozzle is really hot and is melting the plastic and fusing it layer by layer onto the print. Again, this is a great way to do prototyping for your projects or make various enclosures. You know, I made the camera enclosure. We've got the printed this as support for the camera enclosure. And the other thing that we're working on right now is a kind of a headset mouse. So we've got an enclosure that designed for that as well. So you could do a lot of really cool stuff with 3D printers and get a lot of really good detail in terms of being able to do some really fun things with OpenSCAD and being able to prototype for all of your projects. So since this print is going to take about 45 minutes to complete, I'm not going to sit here and watch this whole thing. So I'm going to go back to the computer. So right now it's showing our print, it's showing how much time we have, our total print time, our time remaining, and it's going to we can check on the status using Octopi to find that out. And we used OpenSCAD to design our print here. We then used Cura to define the instructions for the printer. So we took our STL, we dragged it onto the screen, we created that in Cura, and then you from there can either put it on a memory card or load it into Octoprint and print it from there by selecting what you want to print. So this has been an introduction to 3D printing. I'm going to switch back over to camera view of me to close things out. All right, well, thank you very much for checking out the live stream on an introduction to 3D printing. This is a great way to kind of get into prototyping for your projects and to create accessories for board games or really design little components that you maybe otherwise wouldn't have been able to build yourself. It's a again, great way to do prototyping. I've built a lot of enclosures, a lot of dice boxes. It's a great way to kind of design and print various things. The other thing to keep in mind is that IoT Fuse is right around the corner. Definitely recommend checking out that conference. And right now it's going to be fully digital, so you can learn a lot about various IoT projects. We've got a lot of really big speakers that are going to be at that event. Definitely recommend checking that out. And if you'd like more information on 3D printing, definitely connect with me on Twitter at Chris J. Black, or check out my blog. I've got some blog posts on 3D printing, blackcj.com/blog. And I've also got some repositories on GitHub with OpenSCAD files. So that would be GitHub/blackcj, which is going to provide some code for getting started with OpenSCAD. All of this information is going to be, the slides and all of the code are going to be available online after the fact. And definitely reach out if you have any questions, and stay tuned for some more advanced topics relating to 3D printing. You definitely, again, you don't need to go out and spend $1,000 on a 3D printer. You can do some great 3D prints with low-cost solutions, as long as you've got the right Cura settings and a little bit of time in figuring out how to tweak all of the settings on both the printer and with the software. All right. Well, with that, again, thank you very much, and looking forward to kind of doing some more of these in the future.